Here we are with lesson 14.2, and we're going to focus on sets of real numbers. So there are different sets of real numbers. So we've got three different types within the realm of real numbers. And we're just going to start with the least complex. And we'll work up to the most complex of those sets of numbers. So the least complex set of numbers is whole numbers, and I'm sure you all know what whole numbers are as we work with them all the time. Whole numbers start at 0, and they continue higher up to the next interval, which is a complete value, so therefore a whole number, 1, 2, 3, and so on. This means that they do not have a fractional or decimal value. The next set of numbers we have are integers. And we spent some time at the beginning of the year learning about integers. Integers center around 0. And we say they center around 0 because integers fall on both sides of 0. And just like whole numbers, they continue by including the next interval, which, as I said before, that's a complete value. And so just like with whole numbers, it means that there are no fractional or decimal values. And they continue endlessly in both directions. So as I said, to the left of 0 and to the right, meaning they can both be positive and negative. Excuse me. So as you can see here, there's some overlap with what we know about whole numbers when we talk about integers. And now our next set of numbers are those rational numbers. So a rational number, it can be written as a fraction. And what do we know about fractions? Well, we know that a fraction is a ratio. Hence the word rational. The word ratio is within that. A simple test to see if a number is rational or not is to see if you can write it as a fraction. And so we have decimal equivalents for those rational numbers, and they will either terminate or repeat, which is what we focused on in 14.1. And if they repeat, they go on forever with a pattern of some sort. So let's look at example 1 here. We're going to determine if they are rational. So again, the simple test to see if they're rational, can we write them as a fraction? So we have a, which is just 8. Well, we know that the whole number 8 can be written as a fraction. We talk about this a lot when we are working with fraction operations and we have 8 minus 2/3. Well, the first step is to turn that whole number into a fraction. We can write that as 8 over 1. So it is, yes, rational. B is -3. And same thing, -3 can be written as a fraction. as -3/1. So it too is a rational number. And then we have 6.5. And again, that test to see if we can write it as a fraction. Well, I can write 6.5 as 6 1/2, and I can turn that into 13 halves, which is written as a fraction or a ratio. So yes, this is rational as well. And then our last set of numbers we have are those irrational numbers. So irrational numbers are opposite, hence the word irrational, rational. They're opposite to the set of rational numbers. Meaning these do not fit the definition of a rational number. We know a rational number can be written as a fraction. These numbers cannot be written as a fraction. These decimal equivalents will never end or repeat. And the most common irrational number that we have is pi. So how can we find others? Well, in 14.1 we talked about square roots. So we can find the square root of a number that is not a perfect square. And we know what those perfect squares are because we listed them out in 14.1. So let's look at example 2, and we're going to determine if these are irrational numbers. So A, we have the square root of 25. Well, 25 is a perfect square, and the square root is 5. Therefore, 5 is a rational, therefore, the square root of 25 is a rational number. B, we have the square root of 13. Well, 13 is not a perfect square. Therefore, it's irrational. C, we have 81, and 81 is a perfect square. Square root of that is 9, so this is a rational number. D, we have the square root of 100, which is 10, so that's a rational number. E, the square root of 91. So checking on your list, is 91 a perfect square? And it is not a perfect square. Therefore, it is irrational. And the last one we have is 121. The square root of 121, that is a perfect square because 11 times 11 is 121. Therefore, that is a rational number. So here ends your first video for lesson 14.2.